Hi guys, Audrey here. So today we are going to work on a differential equation. We want to find the general solution of x ln x is equal to y times the square root of 1 plus 3y squared y prime. So let's start by following the steps. The first thing that we always want to do is if we have y prime written, we want to start off by rewriting that as dy dx. So we'll have x ln x is equal to y, 1 plus the square root of 3 plus y squared, dy dx. The next thing that we want to do is multiply the dx over, if possible, and create a very clear x side and y side so that we can separate our variables. In this case, dy dx is not with a plus or minus on its side, so we can just immediately multiply that dx over to get x ln x dx is equal to y times 1 plus the square root of 3 plus y squared dy. Now, I'm going to go ahead and flip sides here. We're thinking of x as our variable and y as our function. So it makes more sense for us to keep the y's on the left side. So I'm just going to flip this, though it's really not necessary. Y 1 plus the square root of 3 plus y squared dy is equal to x ln x dx. Which brings us to our next step, which is to integrate both sides of this thing. So the integral of y, the integral of the y side is equal to the integral of the left side. So the thing that makes this particular differential equation challenging is not the separating of the variables, but it's actually these integrals right here, because we actually have to think about what method do we need to use in order to evaluate these integrals. So I'm going to call the y integral star, and we're going to go over here and look at it separately. Actually, I'll do it in green. So we have y times 1 plus the square root of 3 plus y squared dy. What I notice here is that the derivative of 3 plus y squared is 2y, and I do have that y on the outside. So it makes sense for us to use the substitution 3 plus y squared, giving us du is equal to 2y dy. So I just have to multiply 2 there and then divide by 2. So the resulting integral will be 1/2 the integral, that 2y dy, that thing right there is my du. So I just say, replace what I have left, 1 plus the square root of u du. And now both of those are known forms. I should be able to evaluate them pretty easily. So I have 1/2 u plus u to the 3/2 times 2/3 plus a constant. And then I can just replace all of that stuff back with my y's. So I end up with 1/2 3 plus y squared plus 2/3 3 plus y squared to the 3/2 plus c. And to make this simple, I'm going to actually go ahead and distribute that 1/2 to give me 3/2 plus 1/2 y squared plus 1/3 3 plus y squared to the 3/2 plus c. Now there's one thing we can do here that we don't necessarily have to do, but that will just make this a little bit smoother and cleaner to look at. This 3/2 right here is just a constant. That c is also just a constant, which tells me that 3/2 plus c is just a different constant. Perhaps we could call it C1. So I'm going to rewrite this without that 3/2, 1/2 y squared plus 1/3 3 plus y squared to the 3/2 plus C1, where C1 has just absorbed that 3/2 into the C. We're allowed to do this because it's just a constant. It's an arbitrary constant. So whether or not it includes that 3/2 changes nothing. All right. let's call the x ln x smiley face here. And we're going to go down a little bit. So we need to evaluate smiley face. Well, the derivative of ln x is 1 over x, and I don't have a 1 over x there, so that's not a good substitution. X itself, it's never useful to let u equal to x. So this brings us to substitution seems to fail. We have two different kinds of functions being multiplied together, so this is going to be an integration by parts problem. That x is an algebraic function, ln x is logarithmic. So we're going to think about late here. Our u and our dv, we're going to use late to pick them. So L comes before A in late, so we're going to let u be ln x and dv be x. The derivative of ln x is 1 over x. The integral of x is 1/2 x squared. Now, to be noted, that 1 over x, if I take the derivative again, will become negative 1 over x squared, and we'll just keep like having that x on the bottom have a higher and higher power. We will never get to 0, which means that we stop here in our table. We don't keep going because the possibility of getting to 0 is just non-existent. Plus, if I multiply 1 over x times 1/2 x squared, I end up with an integral that's pretty straightforward. So we just apply our little formula here, uv minus the integral of v du, to get 1/2 x squared ln x. So I'm taking that diagonal arrow and multiplying the things together, minus the integral, so here we're doing the integral of that multiplication, of 1 over x times 1/2 x squared dx. So we get 1/2 x squared ln x. Over here, that 1/2 is a constant, so I can move it to the outside. X squared divided by x is just x, so we end up there. So I have 1/2 x squared ln x minus 1/4 x squared plus a constant. Okay, so now we're going to go back over here to where we were doing the problem. We're actually going to put those integrals, we're going to replace those integrals with the values we just got. So on the y side, what just happened? On the y side, we end up with 1/2 y squared plus 1/3 times 3 plus y squared to the 3 over 2. Remember, we do not put a constant on the y side because we subtract it over to the x side. So kind of like that constant C1 had absorbed 3 over 2, the constant on the x side is absorbing the constant from the y side. And we end up with that. This equals to 1/2 x squared ln x minus 1/4 x squared plus a constant. Perfect. Okay, so the next question is, can we solve for y? So our step 4 is isolate y if possible. In this case, we have a y squared, plus we have 3 plus y squared to the power of 3 over 2. Isolating y in this case is really not something that we are capable of doing. So remember, when we're not capable of solving for y, or when solving for y is just like extra super hard, we leave our solution as an implicit solution. So here we can say, not possible, so leave as an implicit solution. So we have 1/2 y squared plus 1/3, 3 plus y squared to the 3 over 2 is equal to 1/2 x squared ln x minus 1/4 x squared plus c for my final answer. This right here is the general solution. So now just really quickly, we're going to add a little part of this problem. We have our general solution. Now we want to find a particular solution. given that y of 1 equals to 1. So this y of 1 equals to 1 here, this is my initial condition. So remember, to solve for our particular solution, given an initial condition, we just plug in that initial condition. So we're going to say y equals 1 when x equals 1, and we're just going to plug that into our general solution. So we get 1/2 times 1 squared plus 1/3, 3 plus 1 squared to the 3 over 2 is equal to 1/2 1 squared ln 1 minus 1/4 1 squared plus c. So 1 squared is just 1. Anything times 1 is just that thing. So we have 1/2 plus 1/3 times 4 to the 3 over 2 is equal to ln 1, remember, is 0. So this is equal to 0 minus 1/4 plus c. Cool. So now we want to solve for this thing. 4 to the 3 over 2, remember that's like taking the square root of 4, which is 2, and putting it to the power of 3 to get an 8. So we end up with 1/2 plus 8/3 plus 1/4 is equal to c. So c is 6 over 12 plus 32 over 12 plus 3 over 12. C is 41 over 12, which gives us our particular solution of 1/2 y squared plus 1/3 times 3 plus y squared is equal to 1/2 x squared ln x minus 1/4 x squared plus 41 over 12 for our final answer for the particular solution. And that's all. Bye, guys.